So I'll send the uh, paper to the WhatsApp group. Can you hear me, my students? Okay. My voice getting lagged or something? Okay. Yes, in the morning I tested the mic, but lagged. Okay. The fifth one, the group can join it and start to do it. Okay, you can start to do it. Finished. Start to do it. Now one question remains. Right. And I'll send the answers for the fourth week for the group also. So you can take it. I have the fourth week paper. Right. So now just open the fifth week paper and start to do it. Okay. Week paper, start to do it. Paper 5. Right. So right. Okay, so start to do the paper. Just we are going to revise the knowledge. Okay, think you can remember the parts. Frequency equal to uh, reciprocal of time per second minus 1. Check this. This is the hardest question. Okay, time's up. So let's start today's test. Today is August 1st, right? So yesterday, that was a special day. If somebody is watching movies, it was a special yesterday. Marvel released their new but Spider-Man. Don't you watch it? No. Okay. So there was a big weekend, 2 weeks. Uh, so this is let's start this month a fresh new start. Okay. So first of all, I'm going to explain you all the plan for this month because my exams are getting nearer. So I have just shifted 1 or 2 classes. Okay. So here, right, in this month, 22nd and 29th. Okay, mark or write it in your or somewhere else. 22nd and 29th, you won't have the class. Okay, on Saturday. Okay, it will be shifted onto the paper class day, 16th and 20th. This Saturday, this is Sunday. Theory class will be shifted to the Sunday classes. Exact time. Okay, 8 to 12. Okay, so I will be keeping the the paper class on Monday evening. So your school started official, right? Okay. So do you have classes on Monday? No, evening time. No, ne? So I will be uh, starting the class on evening on this Monday, 17 and 24. So if you can join it. If you're so mainly this week, this second, I mean tomorrow, you don't have a paper class, okay? Because paper crew and the paper storage stuff got damaged. So again, I keep this class. So I will be keeping the paper class on this 9th of August. Okay. So most probably this 17th would be discussion day. Okay. So again, this 24th would be a paper, or sometimes this would be a free day. Okay. Right. So I'll mark, if you want, you can mark them. So this would be a discussion day. Okay. Discussion day would be a paper class. Paper class. Sorry. Yeah, this would be a paper. I will give you the second echo paper on 9th. On this day, you have the theory class. On this day, you have the theory class. On these days, you have the discussion. So this 24th would be a holiday, or it would be a paper. Holiday or a paper. Right? So as usual, you would have the 8th, 15th, have the class, theory class. Right? And again, this next month, but September. So September is going to be a big month. You would have some seminars, extra seminars. I mean, I said I will be covering 3 sections in mechanics, right? If you want, you can write them. These blue colors, these are going to be cancelled on theory classes. These will be the official dates, and this theory classes will be shifting to 16th and sorry, not 16th. Yeah, 16th and 23rd. This is a paper, this is theory classes, and paper class will be shifting on Mondays. Okay, right. I'm going to erase this. Right. So today we are going to discuss the weekly paper. We are going to move on to our lesson. Right. So the first question, weekly paper 3, weekly paper 5, weekly paper 5, 5. Okay. What is the first question? This is from the first unit. Okay. Which of the following does not represent a fundamental unit in SI system? Okay. So we have how many fundamental units? 7 fundamental units. Okay. So first 3 you all know it is MLT. From this code you can remember the first 3. Mass, 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 length, and time. Okay, time. And after this you would be having a temperature, 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 and then you have chemistry part. What is it? Amount of substance, amount of substance, amount of substance, that is moles. Okay, and you have candela, luminous intensity, luminous intensity, and this is from biology, this is from chemistry. What is luminous intensity? Light. Okay, you need light for photosynthesis, right? And the next one is again from physics. What is it? Current. Correct. Okay, so these 3 stuffs you have to remember from MLT. Temperature is something related to heat, and other stuff biochemistry and physics. Okay, usually from these 3 parts you can remember it. Okay, so you have 7 fundamental units, right? So the one that is not here is first answer meters, second Newton, kilograms, second and Kelvin. So meters, it is going to be length. Meters, it is going to be length. The SI unit is length. Sorry, length SI unit is meters. And mass, you have kilograms. Okay. Temperature. So usually we write temperature like this, short form. So it is capital K, and then we have time, we measure it by seconds, simple S. So the one that is not a fundamental unit here is newtons, the second option. Okay, right. The second question, the energy of a photon of frequency f is given by E equals hf, the dimension of hr. So this is really easy, right? We did many questions like this. I mean, this exact question we did twice or 4 times, I can remember. Okay, I'll erase this. Second question. So the equation is E equals to hf. This is not working. From here. So this E is energy, H is the what constant? What is this H? Planck's constant, and F. So you can subject this H here. Okay, subject this H. Okay, you can subject this H here. I'm keeping this H at about E divided by F, right? So H is equal to energy divided by frequency. Energy divided by frequency. So I'm going to write the dimension part of E and F. So energy, I forgot what's the dimension unit of energy. So what you are going to do? You are going to derive it. Energy is every time equal to work done. Okay, you have to remember it. Or energy is equal to what? mgh. What is mgh? Potential energy. That's a sort of energy. Or kinetic energy. From those equations, you can derive the unit. Okay. So I'm going to use the work done part. So work done is also an energy. So work done is equals to force into displacement. So I know the unit of force, it is going to be kg ms minus 2, and displacement it is going to be what? Meters, right? If I multiply this and this, I will be getting what? Kg, okay, kg, meters and meters. So 2 meters, I multiply them, it is going to be meter squared, right? And I have seconds per square second. So the dimension of, I mean, the unit of energy is kg m squared s minus 2. I'm going to substitute that, right? So I'll write it here. So this is equal to kg m squared s minus 2 divided by frequency. What is frequency? Number of waves per second. So number of waves in it doesn't has a unit. Number of something means it doesn't has a unit. How many apples? 4 apples. Okay. So it is not mentioned as a physical quantity there if we are counting something. So the meaning of frequency is what? Number of, so if we consider waves, it is going to be number of waves per second. If we take apples, number of apples per second. Understand? So this is going to be, this doesn't has any dimension. Number of something doesn't has any dimension. Okay, but this has a dimension. What is this? Per second. This is a physical quantity, fundamental physical quantity. So the dimension of this is every time, remember, okay, it is going to be per second. Unit is going to be per second. Okay, so dimension is going to be t minus 1, t to the power minus 1. So I'll write it in units, so you understand units per second. So what is the meaning of dimensions, people? Dimension is the code word for units. Okay, so if we take kilogram, the code word for kilogram is m s. If we take meters, the code word for meters is, it's the length and it is capital L. If we take seconds, it is going to be time. So is symbolized by capital T. So temperature, you can mention it as theta. Okay. Likewise, for the 7 physical quantities, for 7 fundamental physical quantities, you have specific symbols to write it as dimensions. Okay. So what I am going to do is I am going to use this unit here because I used the unit for the energy part. So here it is going to be per second. So I'm going to solve this. I'm going to solve this. It's going to be equal to kg m squared s minus 2 multiplied by, I'm going to take this s to the numerator. So that is going to be s negative power. We take to the numerator, it is going to be a positive power. So it is going to be positive 1. Okay. So this is going to be equal to kg m squared s negative to positive 1. Okay. You have powers, you are going to add them. Okay. Same term, powers, we are going to add them. So this is going to be equal to kg m squared s negative to positive 1, that is going to be negative 1. So this is the unit of the Planck's constant. Unit of Planck's constant. So I am going to turn this to what? I am going to turn this to dimensions. So kilograms, that is mass, m. So it is m to the power 1. Meters, that is length. This is L to the power 2. Okay. S, that is time, that is T to the power minus 1. Okay. So the answer is ml square T to the power minus 1, and that is the first answer. Okay, first answer. Right. If you want, you can note it down. Okay. But this girl, Tanushmi. Right. So let's move on to the next question. So this third question, this is a sort of a general knowledge part. Okay. I mean, when you are doing the first unit, it's a general knowledge. If you complete the fifth unit, I mean fifth or sixth unit, it is going to be a theory knowledge. So this is known as the electron volt. Electron volt. That will be, you will be studying about electron volt in the sixth unit, electric fields. Okay. But since you have not uh, done this unit, you have to keep this in mind. Electron volt. Okay, electron volt is an energy. Okay, is an energy, a form of energy. Volt, the sense, the meaning of volt is energy per unit charge. What? Energy per unit charge. So this E here symbolizes charge of an electron. Charge of an electron. Online people, can you all hear me? If something's wrong, just text me. Okay. Charge of an electron. So this is volt. This is volt. So meaning of volt here is what? Energy per unit charge. Okay. If you want, you can write this down. Charge. Okay. Energy per unit charge. So this is like okay. Don't want to mention. I'll mention that in the 60th. Okay. Right. Okay. So the next question, fourth one, question number 4. It is from the measuring instrument part. It is from the measuring instrument part. Measuring instrument. What is the instrument? Measuring instrument part. Measuring instrument. Okay, you have 4 instruments. This is related to vernier caliper. Mainly this is related to vernier caliper, but this is the same principle, that is the traveling microscope also. Okay, so mainly this is in the vernier caliper. So they are asking the what? Least count. Okay, least count. So for least count, count, you have how many equations? You have two equations. Okay, you have two equations. So the first one is a long form and the second one is a short form equation. I'm going to write this like this: long form and the short form. The shortest form is when you have a vernier caliper. Okay, this is the main scale and this is the vernier scale. The vernier scale is going to be shorter than the main scale. But I'm considering only one division. The distance between one division of a main scale and the distance between one division of a vernier scale is comparable, and this is shorter than the main scale. Okay, so the least count of a vernier caliper means the distance between these two. This distance, this small distance. Can you see this? This small distance. This is going to be the least count. This length is going to be the least count. So what you are going to do? You are going to take the length m, this length, and you are going to subtract this length. Okay, right. So in this question, they have given that the length between the main scale is going to be capital M. But this they have not given. Okay, they have not given the length between this vernier, between this first one division of a vernier scale. Okay, right. So we know that I have said you multiple times, the easiest equation to find the least count is length between one main scale. Okay, main scale, main scale, main scale division, main scale division, main scale division divided by what? Number of, okay, number of, you have to remember this is number of vernier scale divisions. I'll write it in short form. Division. This is the same as division. Okay, understand? So this is main scale division in the sense, what is it? This is a length between two main scale division. So that is going to be capital M. Understand? So it is going to be capital M. So this is going to be always 1 millimeters. 1 millimeters. Mostly it is going to be 1 millimeters, but in some cases it is mentioned as 0.5 millimeter when it is an extended vernier scale. Okay, mostly it is going to be 1 millimeters, and in your practical physics practical lab it is going to be 1 millimeter. So they have said that this main scale division is equal to capital M. So this is equal to capital M. This is equal to capital M. Okay, right? After that, they have said that the number of vernier scale divisions in this question is what? Number of vernier scale divisions. Okay, you read and say it. Tanishmi, that's it. If n minus 1 number of main scale divisions are divided into n vernier scale divisions. So n minus 1 is the number of main scale divisions. Okay, n is the number of vernier scale divisions. So they have given the number of main scale divisions in the terms of number of vernier scale division. Understand? Okay, right. So number of vernier scale division is going to be simple n. So the easiest way to calculate this is this. You have to remember this mostly. Okay, so most of the students, after they are finishing the first unit, they are going to remember only this equation. It's a long equation. It's the easiest equation, but they don't remember this, they remember this. Okay, so let's see how to calculate this. So here, okay, you have n number of vernier divisions, and this is going to coincide with n minus 1 number of main scale divisions. Okay, so this is equal to m. So the length here is one division is m, and you have this number of main scale divisions. So it is going to the length of the main scale division is going to be m multiplied by number of divisions. M multiplied by how many divisions there are? There are n minus 1 division. So the length is going to be length of the main scale that is coincided with the vernier scale is this much. That is divided by this much length is divided by this much of vernier scales. Understand? Okay, this is the number of main scale division coincided with the number of vernier scale divisions. So to find the length of the main scale part that is coincided with the vernier scale, I am going to multiply by 1 division's length. Okay, so this is going to be the length of main scale coincided with vernier scale. Okay, this part. Okay, so what I'm going to do is I have to find, so they have not given this length, neither they have not given the length between two vernier scales. So what I'm going to do, I'm going to take this length. Okay, what is it? N minus 1 multiplied by capital M. Okay, and this is divided by n number of vernier scale divisions. So this part is equal to the length between two vernier scale divisions. Understand? Okay, so you have this much main scale divisions. Okay, let's take it is 5. This is divided into 6 vernier scale divisions. 6 vernier scale divisions. 1 2 3 4 5 6. So vernier scales has 6 divisions, main scale has 5 divisions. This length is divided into 6 equal parts. Okay, so I calculated this length. Okay, because I need this length multiplied by 5 is going to be the length of the main scale that is coincided, aligned with the vernier scale. So vernier scale, this division I want to find the length. So this total length I divided into 6 equal parts. Okay, that is what I have done here. Okay, so this is not the least count, right? The least count is going to be what? This length, this small length. What I'm going to do, I'm going to kick off this part. Okay, this is the length of this. So I know the length of this. This is the length. This is the length. Okay, so this is going to be the length, right? And I know this length. I'm going to write it somewhere here. So this m minus this length is going to be the least count. Okay, so I'll erase it again. So what I have to do is I'm going to take this. I'm going to move it a little bit away here. Okay, a bit away here and take this m to here. Okay, m subtract this whole part. Okay, right, this is the long form of the equation. So if you simplify this, you will get, yeah, this, you will get this short equation. So if they have given the main scale 1 division's length and number of vernier scales, you are going to use this equation. Okay, if they have given the main scale 1 division's length and vernier scale 1 division's length, you are going to use this equation. So this is the length of one vernier scale. Length of one vernier scale, vernier scale, vernier scale. Okay, write it down if you want. Okay, okay, so the next part, fifth question. I explain this a little bit again because you have forgotten this stuff. Okay, right, the fifth question, let's move on to the fifth question. In the fifth question, consider the following statements about dimensional analysis. So what is this dimension analysis? Okay, so you have the meaning in the topic itself. Okay, this is the fifth question, white color. So dimensional analysis. Okay, dimensional analysis. So you are going to take the dimension and analyze it. So you can get informations only about the dimension. Okay, you can get informations only about the dimensions of an equation. Understand? Right. So dimension is what? It is another image of units. I mean, units and dimensions are the same things. The only thing is the way that we express them is different. This is by a symbol, this is by the SI units. Okay, right. So what is the first statement? Consider the following statements about dimension analysis. Values of constant of proportionality can be determined. Okay. Disregard the constant proportionality can be determined part. What are they saying? They are saying the values of something can be determined. So in the beginning I said we can only find the dimension part. We can never find the values. The values we can never find it through dimensional analysis. Understand? So the A statement is wrong. Okay. So the B statement. Understand? Understand? Right. The second B statement. Numerical signs of constants can be determined. What? Cut the constant can be determined part. What is it? Numerical signs. So I again said that you can only figure out the dimension or the unit, not the signs or the values. So the B statement is also wrong. You can't never find if the proportionality constant is positive or negative, or you can never find the numerical values of a what? Of a proportionality constant. So to find that, you have to do the practical and collect data and solve the equation. Understand? Right. So the C, what is the C statement? That's it. Units of constants can be determined. What? Unit of the constants can be determined. Yes, I said it. You can determine the dimension part and the unit part. Only that. So the statement C is correct. Simple neither. Okay, that much simple. So the answer is only C. Only C. Third answer. Third answer. Okay, third answer. So the sixth question, we did it again and again. We are doing these sort of questions related to percentages. Okay, so percentage error. This is the sixth question. You have to remember this equation. Okay, percentage error. Percentage error. Error is equal to, okay, the original equation is absolute error divided by what? Divided by reading. Okay, so in this case I said you all, is this different from the equation that I taught you? Yes, this is different. But I said percentage error is equal to least count divided by reading, but here I have written it as absolute error. So now you should remember that I said you all again, absolute error means absolute error, not absolute error means least count. Absolute error in our A-level syllabus is equals to the least count of what? Least count of the measuring instrument. Okay, in the international syllabus it is equal to absolute error is going to be equal to least count divided by 2. Okay, but in our syllabus this absolute error is going to be equal to the least count. You have to remember this, and this is a part related to your new syllabus. Okay, so you have given the absolute error, you have to find the reading, you have given the percentage error. What percentage error? The minimum percentage error. So what I'm going to do, just this, I'm going to do just this. I'm going to transfer this equal sign. I'm going to transfer this equal sign to a inequality sign. What? Inequality sign. Greater than or less than or greater than or equal or less than or equal. Okay. So they are telling this percentage error, 1%. They have given 1% is going to be the minimum. What? Minimum percentage. So minimum in the sense here this should be like this, or okay, it should be a less than symbol or a greater than symbol. Okay, what? Can I figure it out? But the percentage should be a less than symbol or greater than symbol. Okay, you can't figure it out unless you take this reading to the numerator. Okay, the denominator reading. Okay, so what I'm going to do, first of all, I'm going to substitute the values. Okay, absolute error is equal to least count. They have given the least count is equal to 1 millimeters. 1 millimeter. So I'm going to substitute. 1 millimeters. I didn't write any symbol here, okay? I didn't write any symbol here. So here, reading, so I have to find the reading, I'm going to put a capital R, a variable, okay? Percentage error, that is equal to 1%, 1%. Okay, so this percentage symbol, people, this is a mathematical operation. Okay, so if you type this 1 and percentage symbol in a calculator, it will show 0.01. So what is this? Fractionize this. This is going to be 1 over 100. So whenever you are going to write this, you have to simplify this like this. Okay, I'll erase this part. If you want, you can write it. Okay, so I'm going to transfer this to the fraction symbol, and this is going to be equal to 1 over 100, because I don't know to solve this sort of equation with the percentage symbol. Okay, 1 over 100. Yeah, mark. This is not a symbol. I don't know what is here. 1 millimeters over R. So what I'm going to do? I'm going to find this R. That is my final target. Okay. Right. So R is something. Okay. What I'm doing here is cross multiplication. This is known as cross multiplication. R multiplied by 1, R. 100 multiplied by 1 millimeters, that is going to be 100 millimeters. So I'm going to write it as, okay, 100 millimeters. 100 millimeters. Okay. So I got reading is something to this 100 millimeters. So now can you say that this 100 millimeter is something a border part. It should be the maximum or the minimum. Okay, they are asking the minimum reading. Okay, so this reading should be the minimum part. This is minimum, or I mean the reading that we take from the measuring instrument should be lesser than or greater than from the boundaries. Okay, this is the boundary. It should be lesser than or greater than. Greater than. If it is lesser than this limit, the percentage error is going to be increased. Okay, so here the symbol is going to be like this. Every time this reading should be less than the boundary limit. Okay, boundary limit. So here I'm going to transfer this symbol. So if you all remember in your O levels, how do we mark this? This is the 100 part. So R is greater than 100. Sorry. So I'm going to write it again. I'm going to write it like this. Okay. Here you have 100. Okay. I'm going to write this like this and this. Greater than. This is the positive infinity. The positive infinity. Okay. You're going to mark this. So you're not touching this. You're not touching 100 millimeters. But if it is a minimum, it should touch this 100. If not, you can't find a boundary. Why? It can be 100.1, 100.0001, 100.000001, whatever. You can decide it. So if it is going to be a boundary, you should have an equal sign. So the boundary is 100 millimeters. So the symbol is not lesser than, not greater than, it is greater than or equal. Okay. So this is going to be how much? 100 centimeters. So the answer is the third one. Answer is the third part. Right. Okay. Shall we move on to our theories? Okay. Right. Take your tubes. Take your theory tubes. Right. So can you remember what did we do at last? Motion under gravity. Motion under gravity. Okay. So in the final class, what did we do? We did the motion under gravity, and we found the relationship of distance or displacement for nth second. What? For nth second. Can you remember? Nth second. Can you remember? Okay. So what is it? Let's recall it. I'm going to write it in the horizontal direction, this length. So the length is going to be some much higher. This is moving in this direction with an acceleration, E. What is G? Gravitational acceleration. So the displacement for each and every second is going to increase, and the next distance is going to be increased to like this. So the distance is increased. Okay, I'll write it like the distance is increased. Okay, so I need the ratio, people. I need the ratio. What is the ratio? What's the ratio? This length to this length to this length to this. What is it? 1 is to what numbers? Pair numbers or odd numbers? 1 is to 3 is to 5 is to 7 and so on. Okay, so to find this distance, this is a ratio, okay, this is a ratio. But to find the distance, what we have to do? We have to multiply this digit by a magic number. And what is that magic number? What is that magic number? What is it? Factor. We multiply by a factor. What is it? In this equation, S is equal to 2t plus half what squared? AT squared. Okay, I said the factor is going to be this. The common factor is going to be that part. Okay, sorry. So in here it is going to be half, and acceleration is going to be how much? Every time it is gravitational acceleration, and that is equal to 10. Okay, and this t squared, we are finding it to how many seconds? Only 1 second. That is going to be 1. So this common factor is every time 5. Okay, so this is e divided by 2. So this length, the length traveled during the first second is this common factor multiplied by the ratio. 5, this is equal to 5. This is equal to 5 meters per square second. You multiply by this ratio. That is going to be 5 meters. So this distance is going to be 5 multiplied by 3, 15 meters. The distance traveled during the third second is going to be 5 multiplied by 5, 25 meters. This 25 meters. This 15 meters. Can you see this color? This is 5 meters. Okay, so on you can find it. So to find the distance, the relationship between the first one to the second one, first one to the third one, first one to the fourth one. What is this ratio, people? This is what numbers? Pair numbers. This is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So again we have to multiply this by what? Multiply this by the common factor, this by 5. So this distance is 5 meters. Yeah, it is 5. And this is going to be how many? 4 times 5 is going to be 20 meters. So 20 is equal to this plus this, 15 plus 5. This 9 multiplied by 5 is going to be 45 meters. So this is equal to this plus this plus this. 5, 15, 25. It is going to be 45. Okay. So I'm going to finish this nth second part. So we are going to do the solve exercises, and we are going to finish the linear motion under gravity. Sorry, vertical motion under gravity. Okay. Right. So let's move on. So we did the solved question 5, right? Okay. So we're going to move on to the solved exercise 6. Okay. Page number, can anybody tell the page number? 6. Page number 6. Question in theory. Solved exercise 6 here. Okay. Question solved exercise 6, question page number 6. Okay. Right. Let's start and read the question. What is it? A ball projected vertically with an initial upwards with an initial velocity u, time taken to reach a height h is t1. It takes another time period of t2 to reach the ground. Okay, right. So what does they say? They say there's a ball. Okay, there's a ball. It takes t1 amount of time. To reach how much height? H. Okay, and to the remaining part of the motion. What is the remaining part of the motion? This is projected from a ground surface. So it will fall again to the ground surface, so like this. So the second part of the motion is from here. Okay, can you understand that part? Right. So what this they say is the time period for the second part of the motion is t2. This is going to be t2. Okay, this part is going to be t2. Okay, so here I'm going to mention this t2 like this. I'll take another color. I'm going to write this like this. Okay, you ask me a question, why you are writing only this like this, not the next part? So okay, whatever. T2, this is T2. Okay. So you all know when we are starting a motion, the time is going to be how much in our stopwatch? Every time doing the observation with a stopwatch, there is going to be 0. So I mentioned this as T1, not this gap. So if this is 0, and if we click the stopwatch at T1, the gap is going to be T1. 0 minus T1, or T1 minus 0 is going to be T1. So the gap is also T1, right? So I'm not going to write the gaps because I have to use a curly brackets. It's a little bit disturbing. So I'm going to write the times at each and every interval. So T1. Okay. So if this gap is T2, what is the stopwatch reading at this position? What is it? If from here to here it is T1, and this gap is T2, this time period is going to be what? T1 plus T2. Okay, this is going to be T1 plus T2. I'm going to write this information. Okay, right. So now I don't want these parts. I'm going to erase this. Right, from here to here. So what are they telling? Find the following terms of T1, T2 and G. They are saying to find the following Roman number 1, Roman number 2, Roman number 3 in the terms of T1, T2 and G. Okay, first one, find the velocity u. What is the velocity u? What is u? In the figure, do I have given the figure? Figure is there in the book. So they have mentioned u here as the initial velocity. Okay, can you figure that out? So u is every time the initial velocity. So we have to find the initial velocity. So we have to find the initial velocity. So this is solved exercise. Solved exercise 6, Roman number 1. We have to find u. Okay, u means from this. So what are the other data I know? I know the time, I know the acceleration. I'm going to mark the acceleration, it is, and I know the distance. Okay, so I can put an equation for this part, and I can put an equation for the whole part. Okay, for this part and this part, for this part and for this whole motion part. Right, I know the distance from here to here it is h, from here to here it is 0. Came to the initial part. From here to here the time is t1, from here to here the time is t1 plus t2. Okay, from here to here the initial velocity is u, from here to here the initial velocity is u. Okay, the both situations, if I apply the motion equations. Okay, and for both equations, both parts, the gravitational acceleration is g. So I know what is h, that is displacement. What is t? Time. What is u? Initial velocity. What is g? Acceleration. Acceleration. So the equation that we are going to use is the fourth equation, STUA s equals to ut plus half at square. Okay, so I can apply both of these data to find the answer. Both of these data to find the answer. Okay, so which occasion will you prefer, this or this? Which one? Hmm? First or second? So from the first side, you can say you have a t1 plus t2. Okay, so it is better to use this only one terms. Here, two terms. So and here the bonus part in this case is you have no height. That is going to be 0. Okay, but again you can think that in this occasion you are going to apply t squared. Okay, t squared. So you have to what? Simplify t1 plus t2 squared. Okay, you have to simplify that. So it is a little bit disturbing. So I'm going to choose this. Okay, I'm going to choose this. So from where to where I'm going to put? I'm going to put the equation from this place to this place. Okay, right? Let's start. I know the. Okay, start to do with me if you can. So you have to balance the space. You have to write answers for 3 parts to balance the space. Okay, right. So these stuffs that I'm going to write from the white color is going to be the data. Okay, u, and I know the acceleration every time it is g. What g? So I'm going to apply this motion in which direction? I'm going to apply this in this direction. Why? Because I'm going to find u. So if I'm going to find u is in this direction, upwards direction. So if the u to be positive, we have to apply the motion equation in upward direction. If we apply the motion equation in the downwards direction, the u is going to be negative. Why? The u is in the upwards direction. Understand? So I'm going to apply it in the upwards direction. So this g is going to be what g? Negative g. This is going to be negative g. Negative g. Negative g. And after that we have s, that is equal to h, and we have u. Sorry, what is it? T is equal to. Okay. So I'm going to apply the equation. S equals to ut plus half at squared, and then substitute s is equal to h, u is equal to u, t is equal to t1. Okay, plus half a is equal to minus g, side brackets, t is equal to t1 squared. T1 squared. Okay. Okay. So this is equal to. So here we can subject this part. ut1 minus t1 squared divided by 2 is equal to h. So I have to subject u, this part. I'm bringing it to the left hand side. ut1 is equal to. So I have a negative part in g squared. So I'm going to take this to this direction. Okay. I'm going to take this because this is negative part. I'm going to take to this side. It's going to be t1 squared divided by 2 is equal to t1 minus h. Okay. I'm going to write. Sorry. I have to substitute this name. Sorry, I forgot. I have to subject u. Okay, I have to subject this. I'm going to take this u. Okay, this u again. ut1. I'm going to keep this here. Keep this part here, and I'm going to move this gt squared here, plus this gt part here. Okay, gt part here going to be plus gt1 squared divided by 2. So here I have u and t1. I'm going to divide this t1 by t1, and this side I'm going to divide by t1. Okay, this is exact the division part. If I'm multiplying it by the fraction reciprocal of t1, it is equal to the division of t1. So here this is going to be cancelled. So I can write u is equal to, I'm going to take this to other side, plot the whole equation. So here I'm going to multiply t1 by h. 1 over t1 by h is going to be h over t1. And this by this is going to be t1 squared divided by 2t1. So the final answer is going to be h divided by t1 plus t1 divided by 2. Why? This t1 to this one cancelled off. Okay. Okay. Right. So this is one method. So the next method is we can use this method. Okay. So in this question, they are saying to find the initial velocity in the terms of t1, t2, and g. Okay. And this final answer we got here, do we have t1 and t2? T1 and t2 only one here. So we need t2. Okay. So here we didn't get t2 in this method. So if you want to get three of these unknown terms inside the equation, which equation should we choose? Understand? We need only t1, it is going to be this. If only t2, what we are going to do? We know that we should know the entire time. So you can take an equation like t is equal to t1 plus t and subject this t2, and that is not related because we don't know the whole time duration. So you can apply this part again to the in this method, again in this method. So I'll do in that part also. I think it's a little bit easy, right? So I'm going to apply again the motion equation s equal ut plus half at squared. Okay. So we can put here, we can mention this as A, position B, and position C. And this equation is from A to B, and now I'm going to apply from A to C. Okay, A to C. This is equal to the displacement from A to C is 0 because it came to the original position. Initial velocity t and the time duration is going to be t1 plus t2. Okay, plus half from A to C, we are throwing it upwards. So the g is minus. So the g is minus. So negative g time is going to be t1 plus t2 squared. t1 plus t2 squared. So here I can see that this is equal to 2 t1 plus t2. This is equal to positive, negative, and again positive parts. Positive, negative, 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 positive, again negative. So this is going to be whole negative part. G divided by 2 t1 plus t2 squared. t2 squared. Okay. So here you have an equal symbol. So here you can move on and write it as here 0. So you can take this part, this direction, and write it t divided by 2 t1 plus t2 squared is equal to u t1 plus t2. Okay. So now you can see something, what t1 and t2 is equal to t1 and t2 in the left hand side and the right hand side. So you know that the time from A point to C point is not equal to 0. Okay, you can write that condition here. But t1 plus t2 is not equal to 0, or you can write t1 plus t2 is greater than 0. Okay, So I can cancel this off. But in this side T1 plus T2 to 1 T1 plus T2 here. Okay. So I will get the answer of u at once. What? U is equal to u is equal to u is equal to what? T divided by 2 T1 plus. Now I have T1, T2 and G here. Okay. I have T1, T2 and G here. Part. So if you want to find the final answer in T terms, you can use this method. Okay. If you want only T1, you can use this method. If you want T1 and T2 both, you have to use this method. But you have to write what are the datas. Okay. You can use C here, H, T, U and G here 0, T1, U and G. You can use S equals UT plus half AT squared. For this scene and for this scene, I can apply the motion equation. Okay. So in the question they are saying to find in these terms, so we have to use this method. So I think we have only one. How many steps? Okay. 1, 2, 3, 4 and 5 steps here. Here we have more than 5 steps. 1, 2, 3, 4 and 5 steps. Both are same, but I think this is much more easy to understand. Hmm? Yeah. Okay. Right. So this is for the Roman number 1. I prefer to write this. This is the best option because this is much related to the question. In the question they are saying find following terms T1, T2, T. Okay. In this question they are asking to find the answer with T1 and T2. Right. Let's move on to the Roman number 2 part. Roman number 2. So they are asking to find the height. Roman number 2. Roman number 2. Roman number 2. So they are asking to find the height h. They are asking to find the height h. I'm going to draw the figure again here like this. Okay. H T1 1 plus 2. Okay. This U and here I have G. So they are saying to find this H. Okay. So I have to find H and I know the value of G. I know the time period for T and what is the next data, Here we should know velocity and initial velocity also. So only 5 variables we have. Okay, we have to check. We know this. I mean, we have to find this. We know this. We know the time. Do we know the final velocity or the initial velocity, people? Final or initial velocity? Right. Have found the initial velocity from the Roman number 1 part. So we know the initial velocity. So again, what I'm going to do, this is displacement, this is acceleration, this is time, and this is initial velocity. I'm going to I'm going to use the S equal ut plus half at squared equation. So I don't know this. Okay. So I'm going to use this S equal ut plus half at squared. So I'm going to use this equation from A to B. So from A to B, I'm going to substitute this equation. in the vertically upwards direction, S is equal to ut plus half at squared. Okay. Fine. Right. So the displacement is h. We are going to find h. Initial velocity, I am going to keep it as u. Okay. Time is going to be t1 and half, since in the upwards direction the acceleration is going to be minus g, time is going to be t1 squared. Okay. So here we have the time, the gravitational action and the time. So what is the value for u, people? U is going to be the initial velocity. From the first question we know that. So here we are going to substitute the value. Substitute u is equal to what? Half g t1 plus t2. I'm going to substitute this value. Why? We have the t1 and t2 in this equation. Okay. So I'm going to substitute this here. So the value is going to be h is equal to initial velocity half t1 plus t2 again multiply by t1. Okay, t1, and this part, and this is going to be minus half t1 plus t2, t1 plus 2. Okay. Wake up. Okay. Sleepy. Januka. Okay. In this early in the morning, so you get sleepy. Headache. Sick. Everyone is sick. Okay. Right. If it's hard, you can keep. Okay. So after this, what we have to do? We have to find the h. So I can take the common terms half g, okay, t1 plus t2 and t1 plus t2. Yeah, what is, did I do something wrong? Ah, this is t1 square. Okay, thank you. This ne? Sorry, this is going to be t1 square. Okay. I got my code. Okay, right. Thank you. So this color. This is going to be t1 square. Okay, t1 square. This part here, and I substituted u to here and this here. So I'm going to take the common parts. It is going to be I can do something like this. So I'm going to solve this side, but I'm going to solve this side half, okay, half t1 to t, that is going to be t1 squared, and again I'm going to multiply half and t1, half t1 t2, okay, t1 t2. I'm going to multiply this part with this term and t1 term. Okay. So after that, I'm going to complete this part again, half t1 squared. So you can see that this part and this part are the same. Okay. So you can cancel this out. So you will get half t1 t2. Or you can do another thing like this. It is more clearer, I guess. But you can take the common parts from here. You can take half g t1, half g t1. You can do this way also you can do it, solve it like this. H is equal to, I'm going to take the common parts. What is common here? Half G, a T1 and a T1 from here. Okay, so I can take half G, T1 from here, from both of them. So in the first part, we have only T1 plus T2, T1 plus T2. And from the second part, we took half G and 1 T1, half G and 1 T1. So we have minus T1, minus T1. Okay, understood? So here you will cancel off these two stuffs. So you will get half T, T1 and T2. Same answer. Okay. Little bit quiet. That is okay. Right. So let's move on to the third part. You're writing, right? Take the note. Sure. The third part. Right. Let's go to the third part. Maximum height reached by the ball H. So they are asking maximum height. Maximum height. Okay. So the maximum height. Third question. So again, I'm going to draw the figure like this. You have the ball, you have the ball. So this is H, the maximum height. So we have to find the velocity and we have to substitute the values. Okay. So here the initial velocity and here one time period and here you have T1 plus T2. Okay, right. So you know that what is the equation to find the maximum height? The equation to find the maximum height, what is it? You scared? V squared? What is it? It is Hm is equal to U squared over 2G. U squared over 2G, right? So in this equation, you can substitute the value of U that you obtain from the Roman number 1 and find the answer. That is the shortest method, okay? But can you remember which equation we use to find this U squared over 2G? But okay, let's find it. So I know that from this point. So this is a new point. Okay, this is a new point. This is A, this was B, and this was C. So I'm going to write this as D. The maximum point is D. Okay, so from A to D, I'm going to substitute. Okay, so I'm going to write the data here. From A to D, I have to find the displacement length. And from A to D, do I know the time period? No, I don't know. Okay, so I'm going to write time, I don't know. I know the displacement time, I don't know. And initial velocity, yes, I know. Okay, so what's the next? The physical quantities. 5 physical quantities. Next one, final velocity. Acceleration. So that is gravitational acceleration, I know it. So the next one is final velocity. So from A to D, what is the final velocity? Do we know? Oh, that's it. It is 0. Why? When we reach the final destination, the maximum height, the velocity is going to be 0. If it has a velocity, it should move upwards. Okay. From this point, it is going to be a free fall. Okay, a free fall. Understand free fall in the sense it is going to move with an initial velocity of 0. Okay, like we are putting something down. Okay, right. So the final velocity is going to be 0. Okay, here this t. Let's talk about this later. Right. What I'm going to do, S U A V. The equation is going to be what? V squared equals to V squared in the upwards motion, V squared equals to U squared plus 2AS. Okay, now let's move a little bit faster. V is equal to 0. Okay, U is equal to what? U is equal to? Okay, let's write that step here. So I'll write it as U squared for now. And plus 2, A is equal to minus G, S is equal to capital H. We are going to find this. Okay, understand? So here I'm going to substitute the value of U. Substitute U is equal to what? Half G T1 T2, T1 plus T2. I'm going to substitute this. Okay, so I'll get 0 is equal to U squared. So half G T1 plus T2 squared, whole part squared. Oh, big part. Okay. Positive, negative, 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 positive, negative. What is this? Can't read my letters. Minus positive, negative, 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 positive, negative again. So negative capital H. Okay. I have a 0. Wow. Now it is going to be a little bit easier than I thought. So this part I'm going to take to this side. So 2GH is equal to half G T1 plus T2 squared. What squared? Whole part squared. Okay. Whole part squared. Now what's the step I'm going to do? I have to subject this H. Okay. So I'm keeping this H here and moving this 2G part to the denominator, this side. Okay. So before that I can do something. What? So here is a square root, right? Here is a squared value. So to simplify this, I can take the square root of both sides. Okay. But if you take the square root from both sides, you will get a square root value in this H also. So you can do in the both way. You can take this to the other side and take the what you can substitute. Ne? So you have to solve a lot of stuff. Okay, let's see. Take the square root. Yeah, okay. So I'm going to take this. Sorry. So I'm going to keep this half and t and 1 plus t2 like this. Add values. Cap bracket. So this is going to be like this. Okay. So now I have to simplify this. 1 over 2g. I'm going to take the square parts of everything. Half is going to be 1 over 4. Squared belongs to this, squared belong to this, squared belong to this, every part. Okay. I'll write in kr belongs to this and to this whole part. So I'm going to express that. Yellow. So this is going to be g squared plus t1 plus t2 squared. Okay. So this g2, this one g cancels off. Okay. So I will get the answer as we have this. Every time you have something, just circle it off. So you will remember what are the stuffs here. Okay. So this is going to be, so denominators 2 and 4, that is going to be 8. Numerators g and t1 squared. So g t1 plus squared. Okay. Right. Okay. Did I do something wrong? Oh. What is it? Something wrong here? No? This. Yeah, yeah. This is the original way to find this. So I have a small shortcut also. Okay. Let's see what is it. What is it? H plus. What is it? You know the whole time period, right? Okay. So this is a motion without no any air resistive forces. Okay. The motion without no any air resistive forces. So the first part of the motion is equal to the second part of the motion. So the total time is equal to t1 plus t2. First part and second part takes the same exact time. So time to reach the maximum height is Tm is equal to what? Total time divided by 2. So you know the time, you know the initial, sorry, I don't want initial velocity. You know the displacement, I mean, you have to find it. You know the final velocity and you have the acceleration. This cat, what is this? Uh, equal u plus 80, v square equal u square plus it is. No any equation. No any equation. That is because I forgot to tell you a special characteristics. If you take 4 of the equations, you need initial velocity to solve 4 of the. Okay. So here you don't have 4 what I mean initial velocities. So I said you have 5 variables, but you have only 4 main equations. But you can derive the 5th equation, right? So the 5th equation is going to be something like this. Okay, so I'll write it from my memory. This is going to be dt minus half t squared. Oh, sorry, not half. This is going to be the 5th equation, half dt squared. Okay, the 5th equation. This is not really important. I mean, we can't use this to solve questions, but we can derive this and use it. Okay, so let's see if we get the exact part here. Okay, so capital H, this part is going to be 0. Why? Final velocity is 0. negative 1 over 2, g is going to be minus g. Okay, t is going to be t1 plus t2 divided by 2 scat. Okay, this just an extra knowledge for you all. Okay, extra knowledge. So you will get the exact part, half minus negative negative positive, so g here. So here you will get t1. I can expand this and write. Okay, I can write this in the expanded form, t1 plus t2 squared square, so t1 plus t2 square and 2 square. So you got the, sorry, 2 square. So you got the exact equation, right? Okay, so here you got, here I'll write it like this. You can write the part also. So don't write this part, just write it in your notebook if you need. So this is going to be equal to, I'll write it here, you'll get the exact part. Half, you had a 2 and you had a 2 squared, right? So it is going to be 4 times 2, going to be 8, and you had a t1 plus t2 squared, and you had a g. So this answer, get it? Okay. So if you want to solve MCQs much faster, you can remember this equation. Okay, the fifth equation. Right. Okay. So let's move on to the seventh question. Let's move on to the seventh question. So are you okay with motion under gravity? You still improving. So if you have any questions, you can ask. Okay, you can ask. Right. Let's move on to the seventh question. Seventh question. A ball released from a height, 20 meters, rebounces with a velocity of 3 over 4 times of the velocity it strikes the ground. What is the time gap between the first rebounds and the second rebounds? Okay, first rebounds and the second rebounds. Now we have to think. Okay, so here what they have said, they have a ball, okay, they have a small ball, they make it fall down and hit the ground, and the second part of the motion is this ball rebounces and come to the next point. Okay, rebounces. So they say that the initial velocity of the second part, I'll write it as first and the second, this is the rebouncing part. So this velocity is u, this is u, this is going to be u, and this velocity is going to be v. So they say that after rebounding, this u2, I'll write it as u2, u2 is equal to final velocities, I'll write it as v1. v1's what part? Rebounces equal to the first rebound, second rebounds until the ball in the velocity is 3 over 4 times. So this is going to be equal to 3 over 4 times. Am I correct? So this is 3 over 4 times. I'll write it like this. Okay. So what I'm going to do, I have to find the gap between the first rebounds and the second rebounds. Okay. Gap between in the sense the time. What is the gap between the first rebounds and the second? Okay. So here you are putting this ball downwards. Okay. So here it crashes, strikes the ground. So this is going to be the first bounce. Okay, it hits the ground and moves upwards. So that's the first strike. So again it comes and hits the ground. So this is the second strike. So they're asking the gap between these two strikes, this strike and this strike. Okay, so what is the gap? I mean, they're asking the displacement or the velocities or the time. The gap they're asking is not displacement, right? Both of them are in the same position, right? So it is 0. They're asking about the time. So what they're asking is from here to here, let's take it as t1. From this part to this part, it take a total time of flight like t2. So from here it is starting a nib motion, right? From here it is starting a nib motion. So this time period is the gap between the first strike and the second strike. Understand? Okay. So my target is to find this T2. Okay. So I have to move to the second part of the motion. To move to the second part of the motion, I have to find the initial velocity. So before going to this part, I have to find t. Okay, I have to find what? I have to find t. Okay, I know the initial velocity. Why? From this equation, I can find the initial velocity. So I know the initial velocity. I have to find t. This I know the what acceleration, and from this position to this position, what is the special characteristics? Displacement is 0 because to the same initial position. So from here to here, this is the initial position, this is the final position. So at the same level, so the displacement is what? 0. So the displacement I know is this. So I have to apply this equation, but I don't know the initial velocity. So this initial velocity is the final velocity of the first motion. So to find the first final velocity, I have to apply motion equation to this part. Understand? Okay. So first I'm going to start by the first part of the motion. Okay. Right. I'll write it as the solve exercise 3. Solve exercise 3. So here for the first part of the motion. So the first part of the motion, I have to find velocity. I know the acceleration. They have given the time period t1. They have given the time. No, they have not given. I know the initial velocity, that is 0, and they have given the height. Have they? Yes, they have given the height. So I know the s. Okay. So I'm going to use this equation. And find velocity here. Okay. And I'm going to put this velocity to here, and I'm going to find this initial velocity here. And by using these variables, I'm going to put this, and find what? This t. I'm going to find this t. Understand? Okay, right. So I'm going to start from first part, then move to second part, find this, and move to the second part and find t. Okay, right. So let's draw another diagram to mention these data. Okay, this is the motion. This is the particle. It is coming from here. The particle is going upwards and coming to here. So this is 20 meters, and the next part is okay, this is the only data they have given, and the next part is this u2 is equal to 3 over 4 v1. Okay, 3 over 4 v1, 3 over 4 v1, right? So this information I'm going to write this as a prep. I'll write it here. Okay, right. So this is for your knowledge. Okay, you can write it down, or you can mention these stuffs in your notebook or whatever. Okay, I'm going to apply the motion equation for the first part of the motion. What is the equation? VUAS. What is it? V squared equal U squared plus 2AS. So I'm going to apply for the first part of the motion. If I want, I can mention the places here, but this is just only the one direction, only one path. So I don't want to write it from A to B or something, because it is just a straight line. So I can put this equation, which is V squared equal U squared plus 2AS. But you have to keep in mind, I'm putting this equation towards the ground. This is towards the ground. He is in this direction, and this motion is in this direction, okay, this direction. This motion is in direction. Understand? So here I am putting this equation in this direction. So the gravitational acceleration is going to be plus. Okay, I wrote the equation, right? I have to find V. I know the U, it is equal to 0. I know the acceleration, that is equal to plus G or minus G. Plus G. Then 10, the displacement, it is 20. Okay, I'm going to substitute. This is towards the downwards direction. Okay, towards the downwards direction. Velocity, we have to find it. Initial velocity 0 squared, is V squared, plus 2, A is equal to 10 plus 10, displacement is equal to plus 20. So the velocity is equal to, this is 0 ne? So 2 times 10, 20, 20 times 20, 400. Okay, you can do it. 20 times 10 is 200, 200 times 2 is 400. So V squared is equal to 400. So V is equal to square root of 400. So V is equal to how many meters per second? Square root of 4 is 2, square root of 100 is 10. So it is 20 meters per second. Okay, 20 meters per second. First part of my question is finished. Okay. So you can write a statement if you want. Here the time gap between the first rebounds and the second rebounds is equal to the total time period from the first rebounds until the ball hits the ground again. That is T2. Find the velocity of the ball striking the ground first. Okay. You can write this statement. Shall I? You want to write that part? Okay. I mean, it is the description about the time gap. What? The gap between the first rebounds and the second rebounds is equal to the total time period from the first rebounds until the ball hits the ground again. Okay, that is the statement. Okay, so we found the first part. I'm going to move to the second part. Okay, second part. So second part, before moving to the second part, I need the initial velocity of this. What I have to do? Before moving to the second part, I have to find the initial velocity. Okay, let's find it. So u1 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 is equal to 3 over 4 e1. I mean this. Okay, this is equal to 3 over 4 20, and this is equal to this to this. How many 4s? 5. 5 times 3, 15 meters per second. Okay, so we are going to move to the second part now. Second part. I'm going to apply to this part of the motion. You can move like this and come to this point. So gravitational force in this direction, UTAS, the equation is S equal UT plus half AT squared. So applying that in which direction? In the upwards direction. S equals UT plus half AT squared. So we have to find this time. So S is equal to 0. Okay, so before that I'll write everything. So S is equal to 0. S is equal to 0. U is equal to 15 and A is equal to plus or minus the upwards direction. A is equal to minus 10. Minus 10. E is equal to question mark. We have to find t. Okay. Online students, I'll okay. So let's substitute this. So now you have a 0 to the displacement part. So you will know this again. 15 time you are putting t, and here you know that if this is minus 10, this whole part is going to be negative. Okay. Now we have to surpass that method, that step. Okay. So you know that this is going to be negative. So this whole part is going to be negative. Okay. So I'm going to write that negative here. So half. Now a is going to be 10 here. A is going to be 10 here. I'll write that 10 here. Okay. Understand? You? And I'm going to write this t squared here. T squared. Alright. Right. So here, as we did in the previous questions, this part I'm going to take to this side. So it is going to be 10 divided by 2, 5. 5 t squared is equal to 15t. So you know that we can nicely cancel these two. But before that, we have to write here t is not equal to 0. So it is much easier if you can write t is greater than 0. Or this, or this. Here you can write this or this as you all wish. So now I can cancel. Now I don't want to cancel anything. So I know if you cancel this to this, you will get t is equal to 5t is equal to 15. Okay. You know that if you cancel, this is going to be the answer. So t is going to be equal to this divided by 5, 1, this divided by 5, 1, this divided by 5, 3. So time is equal to 3 seconds. Time is equal to 3. Therefore, let's write a small part. Time gap between the first and the second rebounds. Between the first and the second rebounds is 3 seconds. Final answer. Right. Shall we move on to the 8th question? Okay. 8th question. An object is projected vertically upwards. Okay, you'll finish writing it. Right. An object is projected vertically upwards with a velocity of 100 meters per second. Okay, right. Another object is released at the same time from a height of 100 meters. Okay. The path. Right. In the path of the first object. Okay, so the second object is released in the path of the first object. Okay. What they are saying? One ball released from up, one ball projected up the same path. So they are going to get collided. Okay. This is from a height of 100 meters per second. Sorry, 100 meters. And this is projected with a velocity of, sorry. This is 100 meters and this is 100 meters per second velocity. Right. The path of this. Find the time taken until the collision of two objects and the displacement to that place from the point of projection. So we have to find the collision point, okay, and the distance from here and the time taken to this. Okay, I'll take that time as t. So in this sort of question, you have to be a little bit cautious. Okay, the reason is displacement to the projection of the first object, displacement to the place from the point of projection object. Right. So here you have to keep in mind, they say that projected vertically upward, another object is released. Highlight this sentence, at the same time. Okay, at the same time. Highlight it. At the same time. So what is the meaning of at the same time, people? What is at the same time? So they are saying, trying to say that the time is equals to 0 here and the time is equals to 0 here. So one of my friend is holding the ball there and I'm going to throw the ball from downwards. Okay, so I'm here, I'm going to throw the ball, and one of my friend is on the top of a building holding the ball here. Okay, holding the ball here. So here we have a big clock. We have a big clock, right? We have a big clock. So I'm telling my friend, okay. So when the clock strikes sharp 12 a.m. sorry 12 p.m. we are going to do this experiment. We are going to drop the ball. I'm going to throw the ball. Okay. So now the clock is ticking and now it is exactly 12 p.m. Okay. So I'm throwing the ball with 100 meters per second and he's releasing the ball. So now I have a stopwatch in the other hand also. So I don't need a stopwatch. I'll keep a stopwatch for safety. So this ball is coming by increasing its velocity. This ball is going upwards, decreasement of velocity. So there can be two types of collisions. But this is going and going and going. And before this reaches the maximum point, it collides. Okay. And the next part is, this is coming downwards. Okay, this is coming. But I threw this with like a small velocity. So before these two collide, this reaches the maximum point. Okay, so this will be going downwards. So when this is moving in the downwards direction, this can come and collide this. That's the second. So sometimes these two will be in the same directions, but these two will not collide. Why? Because when the ball is coming from here and here, the velocity of this will be 5 and this will be 2. So both are increasing. So when the velocities increase gradually, they don't collide. Understand? So in these two cases, what is the two cases? Before it reached the maximum height and after it reached the maximum height. So we don't want to care what is happening here, but the only thing is we have to find the time. So before it reach or after it reaches the maximum height. So the ball doesn't collide only when it reaches the maximum height, and after that it is moving with a higher velocity than this. Okay, only that part. So in that part we don't get a time. Okay, so here we have to assume that we are not doing this experiment. Which experiment? Both are not colliding part. Okay, so we are going to find the time. So here it is much easier if we start the question from a simplest part. What a simplest part? The simplest case here is both are getting collided when this is before this reaching the maximum height and this is coming down. Okay, I'll take that for the simple explanation. Okay, right. So now it is 12 o'clock. So I'm throwing this ball and this ball is coming downwards and both of these are meeting at the same point. Both of these are meeting at the same point. So when both of these are meeting at the same point, I am looking at the clock. This one started from t equals 12. I started from t equals 12. So when both of them are colliding, the time will be t equals to 1 o'clock. Not 10, 1 hour. Let's take it as 1 second. Okay. 12 second plus 1 second. Okay, 12 something plus 1 second. Understand? Okay. Then this time, okay, I'll take it as t here. The t2 is equal to 12 5 p.m. on 5 minutes past. Okay, so when I'm looking at this time, both of them are colliding. Okay, so the time this ball took to come to this position and the time this ball took to come to this position is equal or different. Started on 12 p.m. and both of them collided 12:05 p.m. So the gap is 5 minutes for this one and this one. So this time duration will change only if both of them release the ball or throw the ball in different time period. Understand? So in this case, what we are going to do is we are going to take this time as t and this time as t. If not taking this as t1 and taking this as t2. Understand? So in that case, you have to find which person give the ball or release the ball at first, and they will give the time gap between those two. So you can put one as t and next one as t plus the time gap 5 seconds. That's a different case. Okay, you'll get those sort of questions also. Right. So what I'm going to do is I'm going to just write this as t and this is t. Okay. Right. So this parts and this part. Right. This is the position of collision. Okay. This is the position of collision. Okay. So now I know this is 100 meters. Okay. So I have to find this distance. Understand? I have to find the distance from this projection. Which projection? Projection from the collision, the displacement of the place from the point of projection of the first object. Projection means which is a projection. This is a projection or this is a projection? Which one? Drawing is known as a projection. So we have to mention this as the projection. Okay, this as the projection. So this is S. I took this as S. So tell me people, if this is S, what is this? That is going to be, if this is 100 meters, total length is 100 meters. If this is S, this is going to be 100 minus S. 100 minus S. All right. Right. So what I'm going to do, I'm going to put motion equation and find the part. Right. So first of all, I'm going to find the x and then find the value for t. Okay. So I'm going to write the data that I know from this, right? Is this solved exercise 8. Solved exercise 8. So the data. In this case, I know the initial velocity. Okay. I have to find the distance. I have to find the time. Acceleration, I know it. And the final velocity, I don't know it. Okay. This, and this. Okay. I said that out of these five, you don't know 3 sort of variables. You have to use what type of equations? You have to use simultaneous. Okay. So let's look in this part also. Okay. What is it? We know the initial velocity, that is 0. The distance, I know it. Displacement, I know it. The final velocity, I don't know it. The time, I don't know. And the acceleration, I know it. Time and final velocity. Displacement, I don't know. Why? This S, I do it as S name. So I don't know 100 minus S is, it is a variable. So again, I can't solve this sort of equation. Why? 4 variables in the sense, 4 variable equations you have, but you don't know 2 unknowns. You have 2 unknowns. So you can't solve it. So definitely we have to use a simultaneous equation. So in simultaneous equation, I'm going to put simultaneously one equation to this scenario and one equation to this scenario. Okay. So first of all, I'm going to start from A. from A to B. Yeah, from A to A. So I'll take this as, I'll take a small time as A to A. It's 10 o'clock, ne? Past 5. This as A to A and this as B to B, which this particle as B, this as A. I'm going to put the motion equation for A. So I don't want this velocity part. Why? Why? Because they have not asked velocities in the question. Okay? And we don't want that part. So I'm going to use only these 4 variables S, T, U, and A. So the equation is going to be the upwards direction S equals ut plus half at square. Okay, right. Displacement is S. Initial velocity 100, time t, and this is in the upward direction. So I get a 10 divided by 2 part. Understand? Time is going to be cat. Okay. So I have an equation S and T, right? So I can keep it as the first equation. Okay. Right. So next what I'm going to do, I'm going to put the same equation. Why I'm going to put the same equation? I don't want velocity. I have this and this. So I'm going to write for the B particle in which direction? Downwards direction. S equals ut plus half at squared. Okay. Initial velocity 0, so whole part 0. Okay. Here it is in the downwards direction, so the gravitational acceleration is plus. So plus 10 divided by 2. T, same time, T squared. What is the displacement? 100 minus S. And this is the second equation. So what can you do to find the T? You can add the first and second equation. Okay. So I'm going to do, I'm going to add first and second equation. First plus 2, I will get 100. First is S, second is 100 minus S. First is 100t minus 5t squared. Second one is 0 plus 5t squared. Okay, 0 plus 5t squared. Yep. Okay. So this to this cancels off. So this to this cancels off. So you get the time as, but 100 is equal to 100t. So t is equal to 1 second. Okay, right? Okay. So now I'm going to find the, I can use whatever the equation. So I'm going to use everything same. I can use this. So in the first equation, S is equal to 100 t. T is going to be 1 minus 5 1 squared. Okay, understand? So this is going to be equal to 100 minus 5 times 1 is 5. So this is equal to 95 meters. 95 meters, right? 95 meters. All right. Okay. Now take a break. Now. So now the time is 10:10. Come at 10:20. Take 20 minutes break. Online students, any problem? Rubesha is not here to do any. So lucky you will have the recording today. Yes. Okay, take a break, take a break. Run, run. 10, 10. Take a screenshot, write the note, online students. So online students, you have to write a paper, write in a paper, every student. You have to write a cheat, take a cheat and write what tutes you all missed. Okay, tutes. If you will have every tute, you have to you don't have to write a cheat. If you don't have any tute, just write it. I don't have this tutes. I'll put I'll put a small text in the group. What what are the tutes that I have given until now? So you can see what you don't have, and you can request that. Okay, right. Okay. Right. Now let's move on to the solved exercise 9. Okay, solved exercise 9. So solved exercise 9. Solved exercise 9. Okay. So in this question, there's the ground level. Okay. They're telling that an object is thrown vertically upwards, and after 4 seconds, object B is also thrown vertically upwards. Object A is thrown vertically upwards, and object B is also thrown vertically upwards, but after 4 seconds with the same velocity of A. Okay, so this is the object 1. Okay, take this as object A. Okay, object A. So you are throwing this with a velocity of u, with a velocity of u. Okay, so after this is reaching a certain point, okay, I'll take it as this point. You started the stopwatch. Here the time was t equal to 0, t is equal to 0, and you stopped the watch when it is t equals to 4, t is equal to 4 seconds. Now the object A is here. Okay, the object A is here, right? I'll mark it as. Now the object A is here. Okay, right. Now after this is 4 seconds, after A reaches to this point and the stopwatch is 4 seconds, stopwatch shows 4 seconds, I am throwing another ball at this instance, and I name that ball as B. This ball as the new ball as B. Now when I am starting to throw this B ball, the A ball is in this location. A ball is in this location. A is here. Okay, right? So here it is t equal 4, and here it is t equal 0 to A ball. Right? You have to keep that in mind, right? I'm going to draw the path like this. Okay, draw the path like this. All right. So what they're asking is find the velocities when A and B collide. That means they are telling that this A and B collides. They are going to meet each other. Okay, and we have to find the velocities when they meets each other. Find the distance from the maximum height of A to the point of collision of A and B. So let's take they meet at whatever a point like this, whatever a point like this. Okay, so we are asking the distance from the maximum height to this location. Number 1, this A particle had the same velocity u. Okay, and B particle has the same velocity u. That means the same experiment is done twice. Okay, with a time delay of 4 seconds. Okay, so if you throw a ball with u and another ball with u, but initial velocity is the maximum height reached by this ball and the maximum height reached by this ball is same. Same. So I said that maximum height depends on the initial velocity u squared over 2g. Okay, so these two are equal to the A ball and the B ball. Okay, right. And the next thing is you have to keep in mind, okay, you release a ball, it goes in this pattern. Okay, the distance increased, so the time delay between these two phases are 1 second. Okay, so you release a ball. Okay, you release a ball, and that is this yellow color ball. Okay, so it reaches this point and the gap is 1 second. Okay, now you are releasing a pink color ball from this place. Okay, Now the yellow ball is here, pink color ball is here. So what is the distance? There's going to be a distance. Okay, that is going to be 5 multiplied by 1. Okay, common factor multiplied by the ratio, that is 1. Okay, that is 5 meters, right? Okay, so I'm going to ask you a question. When this pink color ball is coming to this point, where does the yellow color ball, I mean, what's the location of the yellow ball? It is going to be here. Okay, now the pink ball is going to be here. So the yellow ball is going to be here. So every time you see, you have a gap of how many seconds? 1 second. 1 second. So you release a ball after a certain delay of time, will the two balls coincide or not? Will they coincide? They are moving in one direction. Will they coincide? No. So if you do the same scenario, same experiment, I mean releasing a ball, if you do it in the inverse way, I mean you throw a ball, and after 1 second of delay, you throw another ball. But you throw this yellow color ball, now it is in this location, you throw the pink color ball. So these two are shifting like this, there's a gap. So they are moving in this direction or this direction. If they are moving in the same direction, will they coincide? Never. So if they are saying in this question they are going to coincide, one ball should move in one direction and the next ball should be in the opposite direction. Only in that case these two are going to coincide. If not, they won't coincide. Why? Because of this reason. Understand? So when now let's take these two are going in the this direction they are going. So the yellow ball is here, the pink ball is here. Okay, the pink ball is here, pink ball is here. Okay, the yellow ball is here, the pink ball is here, and after that the pink ball is here, the yellow ball is here. Okay, this part, right? Now the pink ball is going to come here and the yellow ball is here. Okay, and the next time after 1 second, this yellow pink ball will be here and the yellow ball will be this place. So yellow ball is moving like this, the pink ball in that case was moving from here to here, that is in this second. So in between this they will come to a same location because I took one second delay. That's the case. If not, they will meet somewhere here. Understand? If we take a 2-second delay, this yellow ball here, sorry, yellow ball is here, pink ball is here. So the yellow ball here, pink ball here. So the yellow ball here, pink ball here. They will meet in this place. We take a 2-second delay. Understand? Okay. So one will be moving in the upward direction and the next one will be moving in the downwards direction. Understand? So you are going to write a statement, this space provided. Okay, start right. Putting it as Roman number 1. Putting it as Roman number 1. As Roman number 1. Since A and B balls, sorry, A and B are projected with the same velocity, with, highlight this word, with the same velocity since A and B are projected with the same velocity and one after the other no way of collision collision, no way of collision during the what motion? Upwards motion. I mean both of them in the upwards motion. Okay, during the upwards motion. Okay, write this statement for the solve exercise 9 part. 9 people, just tell me if you can hear me. Okay, A collides with B. A collides with B when A is coming back. When A is coming back, coming back after reaching the maximum height. After reaching the maximum height. Okay, height. Okay. Finish. I'll erase this. Take a screenshot. 9 people. Take a screenshot. So below this, I'm going to draw a small diagram. But when I'm throwing A, okay, T is equal to 0. My stopwatch. Okay, this is A and the velocity is U. And then I have the ball B and I have the ball A. This is when I'm throwing the ball B. So here, when throwing A, when throwing B, and after that, I'm going to draw when both of them collide. This is going to be A in the downwards motion. This is going to be B upwards motion. This is going to be the ground, maximum height and downwards. So this is when both collide. Okay, so now here it is T is equal to 4 seconds. T is equal to 4 seconds. Okay, so here we are asking the distance from the maximum height of A, the point of collision of B. Okay, so here we are asking this height, maximum height to here. I'll take this as H. Okay, take this as H. Okay, so here you have two methods to do this, easy method and the hardest way. Hardest way is you have to do simultaneous equation and solve those parts, right? So the easiest way is like this, but it is easy only if you think too much. I mean, you have to think a little bit, right? So this is a little bit confusing. Okay, right, pink color. So I'm going to take T as the time of the A particle, A ball. Okay, this T. So T is equal to 0. In this part, I'll take it as T. Here, time of A now is T equals to 4. Okay, but here is the time the time starts for B particle from this this occasion. So it is going to be 0. Okay. So you see the time of A is plus 4 than the B's time. When it is 0, it is 4. The gap, it is 4. So I can write a relationship that TA is equal to TB plus 4. Will that gap differentiate? Huh? Will that gap differentiate? Why? Because this time, okay, we threw after a small duration. So it can't, decrease or increase that duration because that is time. Understand? So you can write a relationship like this. Okay. Understand? So now in this place, okay, okay. Now what I'm going to do is I'm going to take another color. In this place, the time of A, it's hard to calculate. I keep it like that. So I'm going to find the time of B here. So what is the time of B? So let's take the time of A as T. Let's take the time of B as T. Okay. From here to here is T. From here to here it is T. So the time of A should be, from this equation, it is T plus 4. Okay, right. So if both of them collide in this position, okay, what is the time taken from here to here, people? But this A particle, okay, this is a confusing part. This A particle is ahead in the motion. Ahead by how many time? What's the time? 4 seconds. It is 4 seconds ahead. Okay. This one is 4 seconds delayed after A. Okay. So if both of them are in this place, to travel this distance, how much time should that A spend more than B? What's the gap between them? Is 4. Understand? Understand? So what I'm going to do here is I'm going to find this excess time. So I'm going to subtract, take T dash as the time from here to here, and I'm going to, so if this A from here to here, it is both of them are same part of motion. Both of them were through with the same initial velocity. So if this, I'll take this height as capital H, capital H. So this B and A is the same exact ball with the same velocities. If the B particle took how much time? T times, it took T time to reach from here to here. Okay, A should also take the same time. If A is to reach this height, okay, I'll explain. This is Sinhala. Do you understand Sinhala? Okay, so B කියන particle එක H කියන height උසකට යන්න, okay, 4 seconds spent වුණා නම්, okay, 4 seconds spent වුණා නම් ඒ scenario එකමනේ B ටත් වෙන්නේ, A ටත් වෙන්නේ. why? එයත් project කරන්නේ එකම velocity එකේ. Okay, it's hard to not use Sinhala. Okay, it is also through with the same velocity. හරිද? so H උස A ට යන්නත් යන්නේ කොච්චර කාලයක්ද? T seconds. Okay, B ට මෙතන ඉඳන් මෙතනට යන්න T seconds ගියා නම් H ටත් යන්නේ මෙතන ඉඳන් මෙතනට යන්න T seconds. so A ට මෙතන ඉඳන් මෙතනට යන්න T seconds ගන්නවා නම්, හරිද? and A ට from here to here මෙහෙම ගිහිල්ලා මෙතනට එන්න T dash කියලා ගන්නවා නම්, sorry, මෙතෙන්ට යන්න t+4 කියලා ගන්න. right? මෙතන මෙයාට වඩා 4 seconds ahead of time. So a particle from here to මෙහෙම ගිහිල්ලා to come to this place it takes t+4 seconds. A particle from here to here takes t seconds. So to find this gap, what should I do? t+4 subtract t. Okay, understand? t+4 subtract t, because the same thing is happening in the both situations. A ball is equal to the B ball. The only thing is there's a small time gap. Okay, you have to find this relationship. So this t dash, okay, this t dash, what is this t dash? Time taken to travel from the little confused point of collision, okay, time taken to travel from point of collision. I mean, now A is here, okay. From that point of collision, it is going to travel again to the point of collision. The time taken to travel from point of collision before the point of collision, again to the colliding place. Again to the colliding place. Okay. The time taken by A to move from point of collision before the collision. Now it is in the point of collision. So I am going to name this location as point of collision. Okay. This is the point of collision. Now A is in this place. Now does both A and B has collided? No. So this is before the collision, but in the colliding place. Okay, so I'm looking at the future and I know this is going to collide in this position. So when A is in here, is the position at the colliding place but before the collision. Understand? So that is this statement. Time taken to travel from point of collision before the point of collision again to the colliding place. Understand? Okay, if you understand this case, you are going to understand relativity. Okay, relativity is sort of like this confusable. Okay, so this is hard to understand. Okay, you understood? Did you understand that? Didn't you? Okay, I mean, I know that I'm throwing a ball. I'm throwing this A ball. Okay, I'm throwing this A ball. Now I'm looking in the future. I know that this ball will collide in this place with whatever the stuff. Okay, it is going to collide in this place. So from here to here, it is moving. At this place, I'm going to start the stopwatch. Okay, so it will go in this motion, and when it passes this exact place, I'm going to stop the stopwatch. So this time I'm measuring. This is the colliding place, but when it is here, it doesn't collide. It collides only when it's coming back. Understand? So the time taken from the point of collision, this is the colliding place. I'll write it as a colliding place. Okay, the time taken from the colliding place before the collision. It doesn't collide, it collides when it's coming back. Time taken from the colliding place before the collision to the colliding place again. Understand? You have to understand that. Okay, so that's why this question a little bit harder. If not, without thinking too much, you can write the equation through both of these cases and solve a simultaneous equation. You will get a quadratic simultaneous equation. It is hard to solve. Okay, I'll do in that method also if you want. So from this point, I have to take what? The time that A had taken to come from this point to this point. Okay, right? So I know that from here to here, It took how many seconds? How many seconds? Time of flight 4 seconds. From this point to this point, it took 4 seconds. Okay. So if there is no any air resistance, what is the time taken only to this part and only to this part? How many seconds? Should be divided into 2 parts. Ne? So this is 2 seconds and this is seconds. Okay. So now what I'm going to do, I'm going to blur this part off. I'm going to delete this part. So if the ball is in this place, okay, and if the ball comes to this place, okay, vertically downwards. So if I start from this as the point A and this as the point B, what is the initial velocity if I'm going to write the equation from A to B? What is the velocity here at the maximum height? Is 0. 0 ne? So at the maximum height, whatever the object, bullet or rocket at the maximum height, it is going to be 0. The velocity is going to be 0. So this velocity is 0. Now it has become my initial velocity. Why? Why it has become my initial velocity? Because I have considered that as my initial point. Okay, I took A as the initial point, so it is the initial velocity. Okay, so here this is my initial velocity, u is equal to 0. Okay, so the time taken to this from here to here, the time taken to travel from here to here is how many seconds? 2 seconds. Okay, right. So EU and the acceleration from here to here, A to B, is negative or positive? Positive 10. Okay. So here, can I find the velocity, people? Can I find the distance from here to here, people? Yeah. I can find S or I can find V. Finished. You put whatever the equation. Without S, V equal U plus AT, find the velocity. Without V, S equal UT plus half AT square, you find S. Understand? So that is the question. They are asking find the velocity when A and B collide. So the velocity of A is this much. So before 4 seconds, that ball was here. Okay, that ball was here. So if I'm using Sinhala, මෙයා මේ පැත්තට ගිය ඒ විදිහටමයි මේ පැත්තටත් එන්නේ. ඒ විදිහටමයි මේ පැත්තටත් එන්නේ. So මේ පැත්තට යන්න මේ තැනේදී මේ පොසිෂන් එකේදී මෙයා ගන්න velocity එක තමයි ආයි මෙයා return වෙද්දිත් එතන ගන්න velocity එක වෙන්නේ. හරිද? Okay. So the velocity of B දැන් මෙතන collide වෙද්දී B ඉන්නේ කොතනද? B ඉන්නේ මෙතන. This is a collision because this is a collision. So B is in this location and A is in this location. So if A is in this location before 4 seconds, if it has a velocity same as the velocity here, then B should also have the same velocity here. Okay. So if the velocity is, let's take it as, assume it as 20. So it is 20 in this direction, 20 in this direction. Every time keep in mind, if you go as the same way, you come as the same way. Okay. I can't use single. I didn't practice with single. If not, I know the terms. Mixing with English, single and English, it is really hard. Okay. So the same path, if it is returning the same path, these two motion is the reverse of these two motions. From here to here, it takes a motion. That same motion, if we reverse it, it is going to be in this motion. Okay. So this is the final verdict. If you have a ball, okay, you are throwing it up. And it is going to this part. Okay. And here it is the maximum velocity. It is the maximum height. So it is going to be velocity 0. You threw like this. But for your easiness, if you have to find a distance like this, not from here to here, this is S. So if you are starting from here to here, can you see this? This color? So if you are going to throw in this direction, okay, it is hard to find this distance. Why? You are throwing from here. Understand? So in this case, it would be much easier if you reverse the motion and if you think this as a free fall motion. Motion under gravity, free fall motion. So it is, if it is in maximum height, if the velocity is 0, again if I am putting it down from rest, the velocity is 0. So if you consider this as falling from here and coming to this point, and you take the upwards velocity as the downward velocity, and you put every same equation, you can find this distance. I mean, you can think one, what is this? Not okay. Okay, let's take it as scenario. One experiment, this experiment, you can take it as the inverse of the experiment and solve the equation. Okay, that's what I did here. I took this, break into two parts, and took one part from here and found the velocities. Okay, now shall we write it? Okay, so after you write this statement, you wrote a statement there, you have to draw these three diagrams. Okay, draw these diagrams. So don't draw this pink color stuffs, this yellow color stuffs, white color diagrams, that's all. Don't draw this yellow parts also. Take this edge as here, okay, but you won't understand. Take this as like, take it as edge. So if you go home and if you revise it, you should again remember this. You have to remember this. Students, if you have any questions, just ask. What is the single term for velocity? No. Acceleration. You but you need. For the next diagram, you should write this yellow color part. I said not to write this pink color. Don't write this magenta. What color you? of light. The universal constant. So you are going by, you are moving in a bus, okay? You are going by a bus, and is going in a set what? Say it is going in a 20 meters per second velocity, okay? Now another bus is going to overtake you. If it is overtaking like this, and if it tallies with your velocity, u is 20, if you are 20 meters per second, and if that bus is also 20 meters per second, what will you see? I mean, will you see that the bus is moving, or if you will see that bus is stationary? Like, I mean, relative to you, I thought to explain this without this word. Fine. So relative to you, that bus that is overtaking your bus will be stationary or will be moving with a different velocity. Will be stationary name. Okay. So when you are stationary, when something is moving, you can tell that one is moving than a velocity that I'm in. So because I'm stationary. So when you are moving, and if another uh, particle is also moving, then you can take, you are not moving, you can assume that you are not moving. So to assume that you are not moving, you have to subtract the velocity of yours from the velocity of that. Just think like that. I mean, if you are stationary, you can you can determine the velocity of whatever the object. But uh, when you are also moving with a certain velocity, you can't guess the velocity of the other next particle. Okay, so to find the velocity of the next particle, you should know your own velocity. Okay, so what I'm saying is, trying to say is, if you have a velocity, and if another particles also has a velocity, and that is one case, okay, and that the next particle also like this, take it like this, I'll explain it without a diagram, it's hard. So this is u, okay, now you are staying stationary, 0. Can you see this? And this is u again. Now you have a velocity, meters per second, whatever. Now a train is moving like this, okay, it is moving with a 4 meters per second velocity relative to the earth. I mean, it is moving relative to the earth, and this train is again moving 4 meters per second relative to the earth, okay, and you are also moving with a 2 meters per second velocity, 2 meters per second velocity. So in which case will you see that the train is moving much faster with a much higher velocity? Case ne, this case ne, when both of you are moving, will be reduced, okay. So take it as 4, both of you are moving in the same velocity, then this train, the train is going like this, you are going like this, relative to you, the train will be in the same location. So every time you compare two cases, I mean, you are stationary and you have velocity, and you compare that with same scenario, train moving relative to the earth 4 meters per second, 4 meters per second, you will have different velocities. Either will have different velocities. But you take light, you are stationary, the speed is going to be 1 into 10 to the power 8. 3 into 10 to the power 8. Sorry. 3 into 10 to the power 8. When you are stationary, the light speed is 3 into 10 to the power 8. And what Einstein say is, since the light is an universal constant, speed of light is a universal constant, when you are moving also, the speed of light will be power 8. I mean, just think that you are traveling in this speed, 3 into 10 to the power 8, the speed of light. Then also you will see the light is not stationary, it is moving 3 into 10 to the power 8. So what happens here is, what is it? You think it, or like think it will think this same example, okay, take this, write this same example, think in your free time, then you will understand that the time is shrinking when you are traveling with high velocities. I mean, to make this speed constant, the time is curving. So this is known as relativity, space and time curvature. Okay, I mean, to make the universal gas constant like this, S equal ut, eh? Both of them are traveling the same distance, and in both of that cases, it has the same velocity. I mean, relative to this, it is 3. Relative to this, it is 3. Okay, so this time is changing. That means the time is bending. Think till then you will understand. So in that, by thinking, but by that thought experiment only, Einstein proposed his relativity of time theory. Okay, the beautiful thing. Okay, fine. After you draw this stuff, you have to write a small statement. Okay, write a small statement. Since, since, shall I write it in a book? Since since A and B exist at same height, since A and exist at same height, above the earth, when colliding, their speeds are equal. This is the reason I'm not reading novels. I have to read scientific stuff. If you read this statement from each word to word, you have a meaning. Okay, since A and B exist at same height, above the earth. Why above the earth? Can be below the earth also. Why? When it is thrown from a brim of a well, it can collide in this place. Okay, not that case. They are telling that above the earth, when colliding, their speeds are equal, not velocity. What is this? Their speeds are equal. Why this statement is that much worth? Because at the same level, at this position, when they collide at this position, A is moving downwards while B is moving upwards. I said that when A is at the same location, the speed will be 20 meters per second, and when it is here, will be 20 meters per second. But the direction is opposite neither. So velocity is a vector quantity. Okay? So you take both of these cases, A and B, is the velocities equal or different? Velocities are different. Why? Because the direction is different. The magnitude is equal, but the direction is different. So the velocities are not equal. But if you take speed is not a vector quantity, scalar quantity. So since the magnitude is 20 meters per second, the speed is equal at the same height above the earth level when colliding. Only if they are thrown with same velocities. Okay, if both of them are thrown in different velocities, it will be different. Okay, understand? Right. Did you write this statement? Okay. So after that, you have to write this part, this time thingy. We have to write this time taken to travel. Okay. The collision dash as this time finding dash So write this statement, not this. I'm going to write this same exact equation in a different way. Okay. This point, if the time taken by A, the time taken by A, if the time taken by A is T, time taken by B is T minus 4. T minus 4. Why? Reason? Reason is it is thrown after a delay. Okay, it is thrown after a 4-second delay. Okay, right. So if T dash, next this is one point, we brought a point above. Now the next, if T dash, I took T dash. Okay, is the time taken by A, is the time taken by A to move from the point of from the colliding place colliding place along dash before the collision again for the collision, comma, if T dash is the time taken by A to move from the colliding place before the collision, again, write this again, okay, again to the colliding place, to the colliding place. If T dash is the time taken by A to move from the colliding place for the collision again to the colliding place, the definition for T dash. So what I'm going to write is, I'm going to write an equation to T dash. So T dash is equal to the time of A subtract by the time of B. Time of A subtract by the time of B. Why? Time of B, the initial time of A when it is at the same colliding place. What? T dash is equal to time of A subtract time of B. So in this time of B, you have to write here another color, whatever, write it in bracket or something. Initial time of A in the colliding place. Okay, TA means, write it here, final time of A in the colliding place. An extra part for your deep understanding. So this is equal to, so TA is equal to T. We wrote that. TA is equal to T. Why? T is equal to T. Because we wrote that. For this point, we wrote that if the time taken by A is T, time taken by B is T minus 4. I'm going to write that. Time taken by A is T minus time taken by B. That is equal to t minus 4. And I can find this t dash, it is equal to t negative positive negative e negative negative positive 4. So t dash is equal to 4 seconds. T dash is equal to 4 seconds. T dash is equal to 4 seconds. Okay. Very soon. So slow. You're a bio student, right? You have another 9 more days. 8 more days. What? Oh, I'm bio. 1.5 years. You have a lot of skills to develop. Mathematical skills. Boom. Like this. I have to get practice to my letters. Okay. So what are you doing after that? After that, if this is 4 seconds, again we have to write that time taken by A to reach place of collision from the maximum height is 2 seconds. Okay. So the next point here, I'll write in time. Try to write time taken by A from the maximum height to the colliding place is 2 seconds. Time taken by A from the maximum height to the colliding place is 2 seconds. Okay. What I'm going to do, for object A, I'm going to find the final velocity. I'm going to find the final velocity. I know the initial velocity. I know the time period. I know the acceleration. So V equal U plus AT. So for A in this direction, V is equal to U plus AT. We are going to find V initial velocity at the maximum height 0. Acceleration due to gravity is positive 10. Time is equal to 2 seconds. So the velocity in downwards direction is going to be 20 meters per second. Okay. You have to finish the 10th question also. Okay. After that, whiteboard is smaller. Yes, big whiteboard size of the white. I will take the smart. So this is the gap. Our school, the whiteboard and that, but the white that is a green board actually. It is 5 times, 3 times maybe. Yeah. So that's why I have to write like kindergarten student. It's hard to see, ne? Fine, fine. Right. So the next part. Where's the next part? Roman number 2. Distance from the height of A, from the maximum height of A to the point collision of B. Easy. Roman number 2. From point from here to here, from maximum point to here. So I know the time, write it here. I know the time, I know the acceleration, I want to find the distance, and what do I know? I know the final velocity. So you can't do this. I know the initial velocity. S equal ut plus half kt squared. For particle A downwards, S is equals to u plus half k t squared equal to initial velocity 0, time 2 plus half. A is 10, so I'm writing this 10 here. Okay, time is squared. So S is equals to 0. This is going to be 0. So I'm going to write this like this 0. 10 divided by 2, 5. Multiply by 2 squared is 4. So this is equal to 20. Okay. So during your classes, tuitions, use this time to increase your potential. I used it. So this is like like something like going through a road. Okay, first time you are going through a path, an unknown path, and if you are going in that route the second time, you won't know the directions. Okay, if you are going to the third time, you won't know the directions, but you will just remember I went first time and second time, so you will know the path. So when you are going the third, fourth, and fifth times, gradually you will remember the path. From here I went from here, turn left, right. So when you are going from one place to one place, you have to have a practice. Likewise, if you are coming to a class, you get sleepy. Get sleepy. So first time, the first day. Okay, think that this is the first day of your class. In the first day of your class, you are getting sleepy within 1 hour. Okay, within 1 hour. So the next time you will again get sleepy at 1 hour. And if you sleep at that 1 hour, that is a utter BS. What you have to do is you have to try to be awake another 5 seconds or another 1 minute more than that 1 hour. So the next day you will be able to stay awake for 1 hour and 1 minute. And on that day when you get sleepy, you have to try to be awake to another 1 minute or whatever the time limit. Understand? So gradually that limit will increase. Okay, so and that limit, I mean being awake during a class is not important. Being awake and focusing on the lecture is the most important part. Understand? You have to keep your backbone straight and keep your hands up, whatever, however you have to be focused in that lecture time or what when they are teaching. Understand? If you give your 100% focus to your lecture, then you don't have to spend time when you are learning again. Okay, that is my trick. So when I go to lectures, I however try to be focused on the lecture. So after I go home, I don't want to study again. Why? I have given my 100% focus. So it is like I'm studying again at my home. Understand? So try to improve some sort of skills like writing. Try to write in a much a small hand. I mean, to writing a like this, the time taken to write a like this and a time taken to write a like this is different. Okay, so try to write small letters, and it is much better for bio students to write slanted letters. Right? So when you're writing slanted letters, it is going to be much clearer than writing like this, bola bola letters. Just try and see. Those are some tricks when you start to write. You have to write faster, small letters, and write like this. I mean, a slanted way. Because no one is going to check your note. Okay? No one is going to check. You are the one who is going to check your note. Then that note is for you. So you can do whatever you want. Okay. You can write in Golu Bhasha, it is much better. Okay, without writing in handwritten. That is how you understand. Okay. So no one can understand my note. Okay. I write notes in code words. Okay. I drew some pictures. Sometimes I make some small music from the first letters to remember these stuffs. Okay, you will understand when you are going to other units. I'm using small. I mean, I'm a Mac student, so I don't like to memorize. So I do certain tricks to memorize stuffs. Okay, right. So you have to remember that if you don't have a path, that means you don't have a will to do that. So if you have a will, you should find whatever the way to do that. Okay, so there's a way. If you have a will, try to find that way. So let's move on to the 10th question. We have another 20 minutes. 10th question, it is more easier than the 9th question. Okay, much easier. An object is released from rest from a top of a building. Find the distance moved by it within 5th second of its motion. 5th second of its motion. That is it. 5th second of its motion. What's the distance? 1, 3, 1, 3, 5, 7, 9. 9 times 5. How much? 45. Okay. So how are you going to find this using? So you can't write the ratio is this much. So you are going to multiply by those are short methods. Okay. I said that you can't even use U squared over 2G to find the maximum height. You can use that when you are writing, choosing answers for the MCQs, but you can't write on the essay paper or the structured paper. So every time you have to derive every equation, each and every equation from those basic 4 equations. You can't use the 5th equation even. Understand? Right. So this is how we are going to find. We are going to put motion equation from 0 to 4 and then 4 to 5. Okay. 0 to 4 second and 5 to 5th second. So what you have to find? You have to find the distance. What I'm going to do, I'm going to, I'll draw this diagram, ball coming downwards. During the 5th second, 5th second means if this is the 5th, if this is the second 5, t is equal to 5. If this is t is equal to 5 and if this is t is equal to 4, 5th second means this is the 5th second. Okay. So t is equal to 1 is going to be the first second. So 2 second, this gap. So 5th, so it should be above the 5. Above the 5, t is equal to 5 seconds. That distance you have to measure. So I'm going to measure the distance from here to here and from here to here. Okay. So I can also find like this. I can find the distance from here to here. That is the much easiest way. This is not velocity. So what you have to find is from here to here until the 5th second and until the 4th second and then subtract that. Okay, then you will get the 5th second. Okay, so I'm going to apply equations for the 4th second. So initial velocity 0. I'm going to find the displacement. Time is equal to 4 seconds. Then acceleration is equal to, since I'm releasing a ball, it is going to be 10. Okay, S equal ut plus half at scan. S equal ut plus half at squared. Initial velocity 0. So this whole part is 0. Okay. Plus 10. So I'm writing it as 10 divided by 2. Time is equal to 4 squared. Understand? Okay. Fine. So the answer is 5 times 16. This one divided by this is 5. 5 times 16 is equal to times 160, 80 meters. Okay. So this is from this to t equal 4 second. I'm going to apply this part to t equals to 5 second. So again, I know these exact stuff, only the time is different. So S is equal to 2t plus half at squared. Okay, distance is equal to 0 plus 10 divided by 2, and this is equal to 5 squared. So this distance is equal to 5 times 5 times 5 is going to be 25 times 5, 125 meters. Okay. Therefore, distance traveled during 5th second is equal to 125 subtract 80 is equal to 45 years. Okay, right? Okay, now let's move on to the question tube. So question tube, I think Vihanger do have a question not. I think Vihanger won't have a question tube, so you can go and look. You can try to find that question tube in the group. Okay. So these days, was there any problem in WhatsApp? Logging through laptops or phones or something? No. There's a small issue in WhatsApp. A big issue. My God. Everything got lost. So the thing is, I'm going to shift to Telegram. I mean, parallelly, Telegram as well as in WhatsApp, I'm going to send both same groups. I'm going to open a Telegram channel and a WhatsApp group. In the same, both of the social medias, I'm going to send the notices. I mean, tunes, all the stuff. Okay. So Telegram is going to be a one channel. So in WhatsApp, it will be categorized. Okay. So it's better to, I'll send you a link and you have to join to that group. Okay. So we are using Telegram. I have to use Telegram. Compulsory. Do you know that? Know that? Do you know that? It is compulsory. If you have to go to medicine faculty from in the first try, you should have be used to Telegram. I'll tell why. The best platform for A levels. You have everything. Okay, fine. So let's move on to the question tube. Question tube. I need the question tube. So in the question tube, now you can do every questions without the inclined plane. So you can do that. Right. In the first page, we didn't do the fourth question, right? You can mark it in your notebook. Okay. First page, you have 15 minutes. Okay. The first page, you have the fourth question. Okay. So read the fourth question. I mean, I'm going to just read the question fastly. Okay. And I'm going to tell the way how you are going to solve this question. Okay. You just can write it or write it in a scratch paper and try to do. You have to do these questions at home. Okay. Fourth question. The stone is released vertically down steadily from rest. Okay. Steadily from rest. Distance traveled in 5 seconds. Okay. They're asking the distance. Sorry, fifth question. Sorry, not fourth. Sorry. This is the fifth question. Okay. That mirror question. As shown in the figure, the acceleration of free fall, the acceleration due to gravity, is determined using a photoelectric method. This is the actual method that they have found that the G, I mean the gravitational acceleration, the accurate method. Times taken by the ball which was released at point P to pass the point X and Y respectively are T1 and T2. Show that the gravitational acceleration is equal to this. Okay. What they are saying is this what? This is the light particle. Okay, this is the light particle. A laser beam. they are pointing it towards downwards direction, and they are mentioning one part as x and y. Two parts as x and y. X and y. This is y and this is x. Okay. They say the time taken to this place is t equals to t1, t equals to t2. Okay, t equals to t2. So they are asking to find the h. So they have given the height between these two is going to be h. Okay, and the next information is a and blah blah. Okay, they have given this distance is equal to a. Okay, what you are going to do? What you are going to do? This is the thing you have to keep in mind. From here to here, apply motion equation. From here to here, apply motion equation. Okay, so from here to here, take it as S1. From here to here, take it as S2. Okay, so I'll take S1. I'll take S1. You know S1. You know the initial velocity. I'll take it as U1. Why? Rest 0. Ne? Figure axle free fall. Free fall of photoelectric metal. This is in a free fall. So U1 is equal to 0. So in this case, you know the distance that is equal to A plus H. A plus H. Sorry. The acceleration, that is G. That is G. Okay. And the next thing is from here to here, it is T2. Fine. And in this, from here to here, you're going to apply the same equation. You know S2. Okay. You know the initial velocity U2, that is 0 again. You know gravitational acceleration. You know T1. Okay. So you will get an equation S equal ut plus half at square, S equal ut plus half at square. I mean S1 equals to ut plus half at square, S2 equals to ut plus half at square. Okay. And you know that S2 subtract S1 is equal to H. Okay. Take this as the first equation. I'll take it as A for now. Take this as the second equation, B equation. Second equation, S1 is greater than A. So I'll take this S1 subtract S2. Okay. S1 is greater than S2. S1 subtract S2 is H. In the final equation, you don't have S or S2, S1 or S2. You just have H. So to find that H, you have to make this equation S1 minus S2. So subtract B from A minus B. Then S1 minus S2. You'll get me? Understand? So in these two parts, you will get U1, this is going to be 0, this is going to be 0, you will get something with GT squared, half G2 squared, and you will get half GT1 squared. Okay, so subtract and subtract, you will take half and G outside, you will get T1 minus T2, that is equal to H. Okay, you will get something, H is equal to half G T yeah, T1 squared subtract T squared, you will get something like this. Okay, here what you have to do, have to find G. You have to find G. Cross multiplication, take this 2 here, take this T here, T squared here. So you will get here, G is here, 2 here, 2H, and you will get the same equation, blah blah. Understand? That is the way. From S1, S2, find this difference because you don't know the distance S1 and S2, and you take two equations, S equal ut plus half. Use the same equation and substitute the value, and from here you have to find H by using S minus S2. Understand? Because in the final, every time if they are telling us to show something, you have to look at that final answer. So in that final answer you have H, so we have to find that H. The final answer you have T1 and T2, so you have to use T1 and T2 to derive the equation. Understand? Okay, this is the way. If you want, just when I'm writing on the board, just write it. Okay, I'm going to just discuss every. I took much time to discuss this. Okay, next come to the seventh equation. Okay, seventh equation. Seventh question. Sixth question is a graph question. Still, you can do it, but don't do it. Okay, because I'm going to teach you all how to draw graphs. So seventh equation. You have a deep well, 140 deep well was located near the point of projection. What is the time expended for the particle to reach the base of the well? This is the well. Draw it like this. Draw it like this. The ball was released here. The ball came and strike the ground at this point. Okay. So what are they asking to you? Seventh question. Seventh. Don't have the answer for the seventh. Okay, fine. Near the point for the particle reach the base well. Now you have to find the time expended. From here to here, take it as t. Okay. You know the initial velocity is 0. Gravitation acceleration is g. You have to find the distance. The distance they have given it as 140 meters. You know the displacement 140, gravitational acceleration 10, initial velocity 0. Use the equation and find t. Understand? Okay. Seventh question understood. What is the equation? S equal ut plus half a square. Right? This is a. Okay, this is a. So move on to the seventh equation again. Not that bracket 7. Next 7. Okay. Next 7. A stone is thrown upwards from a cliff of a huge rock as shown in the figure. The time taken for the object to reach the ground is 60 seconds. Find the height of the rock. You have the rock. This is the height of the rock. H. You throw the ball from here to upwards with a initial velocity of 20. Okay. So I know the initial velocity, that is 20. Okay. I'm going to apply the motion equation from A to B. A to B, but it is moving like this. Okay. So the distance is in this direction. Which direction? Downwards direction. So the distance AB, if I take it as A to B in this direction, if I take this direction as the positive, then this displacement is going to be a negative h. So S is going to be equal to negative h. Okay, and A is equal to, if you are applying it in this direction, this is going to be minus 10, and you have to find the time. They have given the time 6 seconds. T is equal to 6 seconds. 6 seconds to reach the ground. From where? It took 6 seconds to reach from here to here. Okay, better to discuss this in another day. Can you do you understand this? So they say that, okay, I'll explain this another. I'm not satisfied because I have to explain it a bit. Okay, you can do every question. What I have to say is you can do the 7th question. Okay, 8th question you have to draw graphs. So just skip the 8th question. Don't do graph questions. Okay, until I explain. 9th question you can do it. Find the maximum height. You can apply u squared over 2g and find it. Just in this textbook, and if you are going to do that in the notebook, write the relevant equation and find it. Okay. 10th question, find the velocity of an object projected vertically upwards with velocity 80 meters per second when returning the point of projection. 18. So, and also find the time of flight. Time of flight is equals to 2u over g. Then 11th one, velocity and the time of flight projected vertically upwards. Right, that is also easy. Find the time taken by rocket projected vertically upwards to reach point 175 above the point of projection. So take S as 175. Okay. Likewise, you can find those answers for these questions. 13th one, you can do it. 14th one, you can do it. Okay. 15, yeah, 16, 17, 18. You can do up to 24. You can do up to 24. I checked it. The break time. Okay. You can do up to 24th question. Okay. So when you get a question to draw the displacement time graph or whatever the graph, you know you can do it. Okay, it is just like you have that, you have those drawing parts in your O-levels, I guess. Okay, but still I will give a good knowledge. Okay, there's a different stuffs in A-levels when you are going to draw motion graphs. Okay, the first in this unit, second unit. So you can do every questions related to motion under gravity, vertical motion under gravity. Okay, after that you have questions regarding the inclined motion under gravity. Inclined motion under gravity. So in the next class, let's try to do the inclined motion under gravity. Okay, so when you are moving to inclined motion under gravity, you should have a good knowledge on this part. in motion under gravity. Okay, so about tomorrow's class. Okay, so what did I say? Tomorrow's is going to be 2nd of August. You can request like this. If you want, on a weekend, I mean on the Sunday class, I can do the question tube. Okay, I mean I stopped doing the question tube because I was planning to start paper classes. Okay, I said I will stop doing question tubes in the paper class and I'll officially start it as a paper class. So if you want, which is better, doing this in the paper class or giving it as homework and giving you the answer scheme? Which is better? Or doing a paper? I prefer to do a paper, but if you don't understand questions, you can take a photo and send it to me. Okay, so I will send the way from by a voice note, or by explaining it using a video. I can send it. Okay, or I will do it in a paper and send it. If you can't understand any of the questions in the tute, just text me. Okay, so vertical motion under gravity is completed today. So the rest of the parts in this tute is inclined motion under gravity. Okay, inclined motion under gravity, it is same as the motion under gravity part. The only thing is you get sine and cos thetas, and cos theta. I mean you get an additionally angle, you get an additional angle here because it is an inclined motion under gravity. You have a theta here. Okay, so if you have a little bit knowledge on trigonometry, is much better, but it's fine. I will teach you all those stuffs. So the next part is relative velocity. Okay, in the same tube you have relative velocity and motion, projectile motion. Okay, so most of teachers doesn't call this as inclined motion. Okay, the most prominent word is projectile motion, projectiles. Okay, prakshipta, projectiles. So you have projectiles in max, a separate lesson. Projectiles in. So when you are going to that lesson in your applied mathematics part, so when you are doing this projectile motion, you will understand. Ayo, this is that easy, because there's a schematic way to do projectile questions in max. Okay, so I will teach you all that method. Is the easiest method to do projectile questions. Every time you just have to do just step 1, step 2 and step 3, you will get the answer. Okay, so likewise it would be much easier for bio students also. I will teach those stuff. So most of the time in this month I will be able to complete this whole tute, and we will be moving to Newton's law of motion. Okay, a little bit hard. Newton's law of motion, in the sense everything is confusable at the first time, but you have to understand every part from small to big. Okay, so did you take the Pesaro books? I couldn't give you all name. Okay, right. So when you are going to have term tests, just you have to let me know. Okay, in which days you would have term tests. Mostly it won't be in here, I guess. This year, I think sometimes it would be. So August is going to be a holiday month, because it is A-level for government schools. So on the next month there will be seminars, September and October. Sometimes you would have term tests on December, I don't know, or January, because they have decreased the duration for A-level students. You'll know that part. Okay, so this batch which is sitting on 2026, 25, I know, 2026. Okay, they are lack of 6 months. No, 5 months. 5 months compared to other A-level batches. Okay, it is unfair. Still they are putting petitions and stuff, but the government doesn't change the time. So you are going to miss like 4 to 5 months compared to other A-level batches. So it is really hard. It's going to be really hard for you all. You have to cover the syllabus and do stuffs and cover past papers. It's really hard. So have to work much more. Okay, try to do every works of this those relevant weeks after you go to home and finish them. If not, it will get accumulated, and after that will be depressed. Okay, don't go to that part. And after you get depressed, to overcome depression, what will you do? You will not consider the homeworks and stuff. I'm not going to do the homework. It's getting accumulated. Okay, you are going to decrease the accumulation in your stress. Okay, so after that, you will be a student of neglection. Have you heard that word? That means you are going to what? Neglect your responsibilities and duties. Understand? Don't be a student like that. Right. Okay. Then done for the day. Bye. So today you will have the recording, I guess. Yeah. Your luck. So goodbye. See you all the next week.